Hello everyone, this is Divyanshi Pathak. I'm second year engineering student at IIPS TAVV Indore. In this video, I'll be explaining you internal 1 papers. In this video, I'll be explaining you question number 4, which is true and false based question. So let's see. First, minimize the number of arithmetic operations variable possible. Yes, this statement is very true because there are several beneficial reasons why we should minimize the number of arithmetic operations. First reason is efficiency. By minimizing the number of operations, we can improve the efficiency and reduce the processing time. Second is accuracy. By minimizing the number of operations, we can reduce the overall errors like rounding errors and improve the accuracy of the result. Memory usage. By minimizing the number of operations, we can also reduce the memory uses and optimize the use of available resources. So overall, minimizing the arithmetic operation can lead to more efficient, accurate with lower memory requirement. So it is very beneficial to minimize an arithmetic operation whenever possible. Now let's move towards next question. Second question says that avoid taking the difference of two nearly equal numbers whenever possible by alternate formulation of problem. If it cannot be avoided, then take the difference before doing other operations. Yes. So this statement is also true because avoiding the difference of two nearly equal numbers and taking the difference between before performing the other operations can help to improve the accuracy and numerical stability of algorithm. For example, here we have two values A and B. A is 1.000001 and B is 1.00002 something. If we subtract A from B, the value of C will be very small. The value of C is that much small that it can be lost due to the limited precision of floating point. So it can lead to inaccurate result and numerical instability. So if we use C for subsequent or further calculation, it will give us error and the answer will be not correct. So taking the difference of two nearly equal number can lead to loss of accuracy and numerical instability. So to avoid this problem, we are recommended to use alternative formulation problem that avoid taking difference of two nearly equal numbers. So we must avoid taking the subtraction of two nearly equal number wherever possible. Now let's move to the third question. Adding or subtracting number, starting with the smallest number and working with the number in ascending order. So, adding or subtracting numbers starting with the smallest and working with number in ascending order can help to improve the accuracy and numerical stability of the calculation, especially when dealing with the floating point number. Why we should calculate or add or perform arithmetic operations in ascending order? Because it reduces the accumulation of rounding errors, numerical instabilities. So for example, here we have A, B, C, D, four variables with values 1.23, 0.004, 45.67, 0.0005. So if we add them in ascending order like B plus D plus A plus C, it will give 46.9035. In this case, adding the number in the ascending order reduces the impact of rounding error and improve the accuracy of our result. So it is recommended to add it is recommended to add small numbers in ascending order. Now let's move toward next question. Does not formulate an algorithm that tests whether a floating number equals 0. So it is not recommended to formulate an algorithm that tests whether a floating point number equals to zero, because floating point number are not exact and their value may be subject to rounding error. This means that when if two floating point numbers are mathematically equal to zero, their representation in memory may different due to rounding errors due to limited precision. अगर हमारे पास एक फ्लोटिंग पॉइंट नंबर है जिसकी वैल्यू नियरली इक्वल टू जीरो है, बट हम उसको जीरो कंप्यूट नहीं कर सकते बिकॉज इट इज नॉट एग्जैक्टली जीरो। अगर हम उसे जीरो कंप्यूट कर देंगे तो मे बी हमारे फर्दर कैलकुलेशन में हमारा जो आंसर है वो इनकरेक्ट आ जाए बिकॉज ऑफ द लिमिटेड प्रिसिजन एंड राउंडिंग एरर्स। सो दैट्स व्हाई it is not recommended to consider a number as zero which is nearly equal to zero. Instead of testing whether a floating point number equals zero, it is better to use threshold or tolerance value to check whether the absolute value of number is sufficient small. This approach is known as epsilon test. So हम epsilon test का use कर सकते हैं to to detect कि ये number is equal to zero है या नहीं। फॉर एग्जाम्पल हमारे पास एक फ्लोटिंग पॉइंट नंबर है x, उसे हमें डिटेक्ट करना है कि दैट इट इज इक्वल टू जीरो और वी कैन कंसिडर इट एज अ जीरो और नॉट। तो हम इसकी एब्सोल्यूट वैल्यू को the absolute function is used to get the absolute value of x and the function return 2 if the absolute yes हम x को absolute function में पास करेंगे if the absolute function returns true because the value it is less than epsilon। इसका मतलब ये है कि x is effectively zero। मतलब अगर absolute value is less than the epsilon value, it indicates that x is effectively zero. So this is also true. Now fifth question, ill conditioning of problem is normally due to improper formulation and can be eliminated by carefully reformulating the problem. A practical way if detect suspected ill conditioning is to alter the parameter by small amount and observe their effect on the solution. So this statement is partly true. Ill conditioning of problem can be due to improper formulation. Ill conditioning means that small changes in the input or parameter of problem can lead to large changes in the output or solution. ए कंडीशनिंग को हम ऐसे समझ सकते हैं कि हमारी एक इनपुट वैल्यू है ए, उसमें हमने छोटा सा चेंजेस करा है या हमने राउंडिंग ऑफ करा है विच लीड्स टू लार्ज चेंजेस इन आवर आउटपुट और आंसर। दिस मेक्स द प्रॉब्लम or it reduces the accuracy of our answer and lead to numerical instability. So this is ill conditioning. So to detect ill conditioning, we alter the parameters by small amount and observe their effect on the solution. This is known as sensitivity analysis. By analyzing the sensitivity of solution to change in the input parameter, we can determine whether the problem is well conditioned or ill conditioned. हम हमारे parameters को थोड़ा सा change करेंगे और हम इस after changing the value फंक्शन की क्या वैल्यू आती है एंड प्रीवियस उसकी वैल्यू क्या आती है, हम उन दोनों को कंपेयर करेंगे। अगर उनमें ज्यादा डिफरेंस होगा then it will be considered as ill condition, and if the difference is not so large, so it will be well conditioned. However, simply altering the parameter by small amount may not always be enough to eliminate ill conditioning. सिर्फ पैरामीटर्स को चेंज करके और वैल्यूज को इक्वेट करने से it is not enough to eliminate ill conditioning. So, in some cases, a careful reformulation of the problem is required. तो हमें reformulation करना पड़ता है, like algorithm को change करना पड़ता है, numerical method को change करना पड़ता है to remove the ill conditioning. So, सिर्फ हमारे पैरामीटर्स की वैल्यू चेंज करना इज नॉट सफिशिएंट. समटाइम्स वी हैव टू reformulate the problem, change the use the different numerical methods also. So this was question number 5. Now let's move toward question number 6. Question number 6 says that after a numerical algorithm is obtained, check if it can lead to numerical instability. In such algorithm, error grow in each step of the calculation. In such case, reformulate the solution procedure to get a stable numerical algorithm. So this statement is also partially true. Numerical algorithm can lead to numerical instability. Yes, sometimes numerical algorithm can also lead to numerical instabilities where error grows in each step. This can be due to variety of factors such as ill conditioning, numerical roundup error, instability, or in the algorithm itself. सो न्यूमेरिकल एल्गोरिदम की वजह से इनस्टेबिलिटीज कैसे आती है, इसके दो तीन रीजंस हो सकते हैं. फर्स्ट, इल कंडीशन प्रॉब्लम, जो कि हमने प्रीवियस स्टेटमेंट में समझा था व्हाट इज इल कंडीशन. सेकंड, न्यूमेरिकल राउंड ऑफ एरर्स, लाइक हम राउंड ऑफ करने के बाद एरर्स जो आता है एक्चुअल आंसर में उसको. और द इनस्टेबिलिटी इन एल्गोरिदम इटसेल्फ समटाइम्स क्रिएट इनस्टेबिलिटी. To ensure numerical instability is important to carefully analyze the algorithm. लाइक हमें अगर न्यूमेरिकल स्टेबिलिटी को डिटेक्ट करना है, इंश्योर करना है, तो हमें सबसे पहले बहुत अच्छे से एल्गोरिदम को एनालिसिस करना पड़ेगा और आइडेंटिफाई करना पड़ेगा किस रीजंस की वजह से इंस्टेबिलिटी प्रोड्यूस हो रही है, किन रीजंस की वजह से इंस्टेबिलिटी आ रही है. If numerical instability is detected, then the solution procedure may need to be reformulated to get the stable numerical method. अब अगर हमारे एल्गोरिदम में न्यूमेरिकल इंस्टेबिलिटी डिटेक्ट हो चुकी है, तो हमें उसे रिमूव करने के लिए रिफॉर्मुलेशन करना पड़ेगा. लाइक एल्गोरिदम को चेंज करना पड़ेगा, जिसमें इन्वॉल्व अल्टरनेटिव न्यूमेरिकल मेथड. हम अल्टरनेटिव मेथड का यूज कर सकते हैं. मॉडिफाइंग द एग्जिस्टिंग एल्गोरिदम को थोड़ा सा हम मॉडिफाई कर सकते हैं to reduce the impact of numerical errors or round of errors. So this was sixth question. This was partially true, and we have discussed why it is partially true. Now, question number 7. Question number 7 says that if severe rounding errors and consequent loss of significance digit is anticipated, and if no alter formulation to avoid this is possible, then carry more significant digit and critical calculation using floating point numbers and double precision mode. In this mode, the length of mantis is twice than the other floating point quantity. So this statement is true. लाइक अगर हम सीवियर राउंडिंग एरर से हमारा प्रॉब्लम आ रहा है, बहुत ज्यादा ही एरर्स आ रहे हैं, तो हम we can use multiple significant digit to avoid this errors. Like this statement is very true. Severe rounding of error and consequent loss of significant digit can occur in numerical calculation. In such cases, if no alternate formulation is possible to avoid loss or to remove these errors, carrying more significant digit and critical calculation can help to minimize the impact of rounding off error. So, अगर हम कुछ किसी अदर मेथड का यूज करके हमारे एरर्स को रिमूव नहीं कर सकते, तो हमारे पास एक ऑप्शन होता है कि अगर हम ज्यादा नंबर ऑफ सिग्निफिकेंट डिजिट यूज करेंगे, तो इट विल increase the accuracy of result as well as minimize the impact of errors also. One way to achieve this is by using floating point numbers. In double precision mode, this can help to increase the precision of critical calculation and reduce the potential for rounding error to affect the accuracy of final result. हम डबल प्रिसीजन मोड का यूज कर सकते हैं टू इंक्रीज द एक्यूरेसी एंड प्रिसीजन ऑफ आवर आंसर. However, it is important to note that increasing the precision of calculation can also increase the computational cost and memory requirement of the algorithm. Therefore, it is important to carefully balance the need for precision against the computational resources. So, इसका मतलब ये है कि अगर हम प्रिसीजन को इंक्रीज करना चाहते हैं, हम like we are using more significant digit to increase the precision of our result. This will also lead to this will lead to more computational calculations, and it will increase the cost of our program, and the memory requirement of the algorithm will also increases. So it is important to carefully balance the need of precision against the computational resources. हमें हमारे नीड के अकॉर्डिंग डिसाइड करना पड़ेगा. अगर यहाँ पे कम प्रिसीजन वाला रिजल्ट भी चलता है तो वी शुड अवॉइड multiple precision technique because it will increase the computational cost only. Or in some such cases, if it is very important to use double precision mode to get accurate answer, so we have to use this double precision method. uh, so हमें अपनी नीड के अकॉर्डिंग डिसाइड करना पड़ेगा कि हमें कब कौन सी मेथड यूज करनी है. Now question number 8. Question 8. Double precision require a large memory space and slow down calculation. As we discussed in the previous question, double precision में हमें ज़्यादा memory लगता है, computational cost ज़्यादा बढ़ जाता है, because जैसे कि अगर हम double precision use कर रहे हैं, अगर एक integer 4 bytes ले रहा है तो double precision में वो 8 bytes लेगा. So memory requirement भी बढ़ गया, computational cost भी बढ़ गया. So हमें अपने नीड के अकॉर्डिंग डिसाइड करना पड़ेगा कि कब हमें डबल प्रिसीजन यूज करना है, कब नहीं करना है. डबल प्रिसीजन स्लोज डाउन द कैलकुलेशन डिपेंड ऑन द स्पेसिफिक कॉन्टेक्स्ट एंड कंप्यूटेशनल रिक्वायरमेंट ऑफ द एल्गोरिथम. ये प्रोसेसिंग टाइम को भी डिक्रीज करता है. So this statement is also true that it requires large memory space and slow down the calculations. Now let's move toward the next question. Question number 9. In third iteration of finding square of root 5 with starting point 7 using Newton-Raphson method, relative error is 0.0013. Okay, so हमें इसमें बताना है कि थर्ड आइटरेशन पर while finding the square root of 5, the relative error is 0.0013. So let's calculate. We are so we have to find the square root of 5. Now the formula to find the value of x nth term is 0.5 into xn plus 5 upon x nth. Here n is the number of 8 iteration, where xn is the nth approximation and xn plus 1 is the n plus 1th approximation. We can also say that nth iteration and n plus 1th iteration. So at first iteration, let's find x of 1. 0.5 into 7 plus 5 by 7. This will give value 3.07143. Now compute x2. 0.5 into 3.7143, which is the previous value x1, plus 5 upon 3.0713. This is also the previous value. So the formula is x plus n plus 1 plus 0.5 into previous value plus 5 upon previous value. So here we have put the value from the previous value. So the value of x of 2 is 2.23862. Now to find the relative error, we will subtract x2 from x1. So the formula to calculate a relative error is xn plus 1 minus xn upon xn plus 1. So we will put value in this formula and we will get the value of relative error, which is 0.0013, and this is true statement. Now let's move towards our last question. The iterative method are compared on the following parameters: the rate of convergence, the amount of computational effort per iteration, sensitivity of method to the starting value and the intermediate value. Yes, it is a correct statement. The iterative methods are commonly compared on the basis of these three parameters only. First is rate of convergence. It refers to, sorry for the interruption, a rate of convergence. It refers to how quickly the iterative method converges to the desired solution. Rate of convergence का मतलब होता है कि how quickly we get the answer in the less iterations, like हमें कितना कम आइटरेशन में हमारा आंसर मिलता है, लाइक हमारा आंसर कितनी जल्दी कन्वर्जेंट होता है, लाइक at the final result आता है. So this parameter is used to compare iterative methods. Second is amount of computational effort per iteration. It refers to the amount of computational required to obtain the next approximation in the iterative process. सो अमाउंट ऑफ कंपटीशन एफर्ट, लाइक हमें कितना कंपटीशन करना पड़ रहा है उस वैल्यू को इवेल्युएट करने के लिए, उस फंक्शन की वैल्यू को इवेल्युएट करने के लिए. सो दिस इज द कंप्यूटेशनल एफर्ट. अगर ज्यादा कंप्यूटेशनल एफर्ट होगा तो हमारा प्रोसेसिंग टाइम भी इंक्रीज होगा एंड प्रोसेसिंग एंड कंप्यूटेशनल कॉस्ट भी इंक्रीज होगा. सो हमें इस फैक्टर को भी ध्यान में रखना पड़ता है. सेंसिटिविटी ऑफ द मेथड टू द स्टार्टिंग वैल्यू एंड इंटरमीडिएट वैल्यू. This refers to how sensitive the method is to the initial guess and intermediate values used in iterative process. A method that is less sensitive to the initial guess and immediate are better methods. So हम इन तीन पैरामीटर्स की बेसिस पर हमारी iterative methods को compare करते हैं. So this is also the correct statement. So that's all for today's videos. Thank you so much for watching my video. If you really liked my video, please like, share, and comment on my video. Thank you so much for watching.